Alright, I ran out of storage, so I had to delete a bunch of videos. And I was just talking about XD. XD is where XD is here. So the formula for XD is 60 times, I have it over here, 60 times ln, so that's life times n over 1 million. And I have 60 times 10,000, which is the life, and times n, which we just calculated here, equals 393.24. That's XD. So we go and for the D bearing, it should be easy because we have AF, we have FD, which is 1.4 from our calculation up here, and then we have XD, we have XO, this should be theta minus XO, and then ln of 1 over R to the 1 over B, and that whole thing to the, for cylindrical, it's 1 over A, where A equals 10 over 3. So the inverse of that, you can see right here, 1 over 10 over 3 equals just to the exponent of 3 over 10. So we grab that, I punch it in, I just find out that the denominator, so I don't have to punch it in again, all that stuff is 0.2196. And I get that C equals 15.89. And then you take your C, 15.89, you go to the special chart, warning, cylindrical bearings only, axial only, which is what we're doing, so I can open it, and cylindrical down here. And again, I said that that was 15.89, and now I can look at C10, okay, so 16.8. So that means I'm fine. It's under that. That's the minimum value. So we go with a 25 millimeter bore, and we're going to be just fine. And that's what it says for the answer here. Choose 25 millimeter bore, O2 series or O3 series. Don't know why we would go there. Don't know what that's about even, but it's available apparently. All right, now the ball bearing, which is angular according to the problem, right? Does it say? Angular 11.7, components of the gear transmitted, the bearing, assume simple supports, ball bearing is to be selected for locations in C, bearing is to be utilized, viable, ball bearing, angular contact, see it says so right there, angular contact, select ball bearing, angular contact. That what that means is, so go back to, now we're back at the ball bearing. On the other side of this, this will be angular. All this is angular contact. This side that's covered, deep groove. So hopefully we won't have to use that, but if we do, we just flip this over. But for now, I'm just going to leave it where it is. It's tucked. So I start by saying the FE. Well, there's the equation for FE, but I don't know some things. All I know is the force of reaction, the force of the axial, and that's all I know for C. So in order to find the effective, the FE is the effective, I have to have a X and a Y. And so what they decide to do, since we don't know anything, just pick the Y2 in the middle, 1.63. And that's exactly what they did. So Y2 equals 1.63, X2 is always 0.56. And then we find the FE based on those things, and that gives us the FE equals 3.65. Once you have the FE, you plug it in, 1.2, which is the AF, 3.65 is the FE, 393.24 is still, because nothing in that equation for the XD has changed, and XD equals 393.24. And now 1 over A, and A for ball bearing is 3. So this is our equation. We get 53.19 kilonewtons. That's our C10. Okay, we have a C10. We have angular contact. We go to the angular contact, and I said it was 53.19. So we see 53.19, 55. And we trace that over where it is a 53.19, so 55. Is that straight? So it's going to go to 60. All right, so 60 millimeters. And then, so C10 is 55.9, C0 is 35.5. So C0 is good to know because we want the FA over C naught. So C0, and we got 53.19, C0, FA over C naught. FA is 1.53. Still, that's just from here. That's from our calculation. C naught is 35.5 from the thing that we just figured out, from the 60 millimeter. And then that's going to be 0.0431. All right. 0.0431 is 0.043. So that's above 0.042, and so it's between those. And then you look at, okay, we need this again, 0.043, and we're going to get 1.85 and 1.71, and we're going to interpolate. So here's my first interpole, 0.042, 0.056, 185. I use the Casio and statistics to get 0.0431, which is the number that we got here, to interpolate between these two numbers as 1.839. So that's my y2 value. X2 is always 0.56. The Fe is the effective force again, and so that effective force is from this equation here, xi v fr. V is 1. We assume it's the inner race that's moving, and 1.839, that is going to be, I don't know, 1.53 looks familiar. 1.839 must be, yeah, that's the y, and 0.56 is the x. And then having a little brain fart, 2.066, what was the 2.066? That is the FR from above, 2.066. So yeah, that's just following the equation. If I had written the equation right above it, it would be helpful, but I didn't. So that cranks out to be Fe equals 3.97. Bam, we can plug that back in. 1.2, 3.97. XD is the same over the same 0.2196. Again, A is 3. That equals 57.85 for our C10. Now we look again to the C10, and we see C10, it was, I just said it was 57.85. So we look for 57.85, and it's between, well, it's underneath 63.7. And 63.7 has a C naught of 41.5, and it is a bearing of 65. So again, I have that data here, and 65 millimeter bearing, C10 63.7, C naught 41.5. Guess what we do with that? We want to go to table 11-1. So we say FA over C naught 1.53 is still from here, from above, and then 41.5 is what we just got from the C naught, equals 0.037. That brings us to the table, 0.037, and that's between 0.028 and 0.042. And then we want our y values, that's 1.99 and 1.85. We're going to interpolate to find our value 0.037, and those data figures that I mentioned, 028, 199, 042, 185, use the Casio, a statistic mode, and plug in the data, 0.037 for the FA over C naught, gives you a Y2 value of 1.9. So 1.9, X2 is still 0.56, and we plug it into, oh, I messed up, I wanted to do C10, but you can't do that. I got to get the FE first, as I said here, and this time, I guess maybe subconsciously I learned from the mistake. I did not, obviously I didn't write anything while I'm commenting here. Plug in the values, 0.56, always the same, 2.066 from above, and okay, so I do have the equation, and then yi, 1.9 times 1.53, which is FA. Oh, that makes it so much easier, because I know where the, okay, I thought I knew, there's the FA, 1.53, and then the FE is 4.064. And that's just from calculating that. All right, I got the FE again. And then it looks like I didn't do any more calculations here. I think I felt like I got the gist. And FE equals 4.064. So let's see what happened here for FE. Did they ever get 4.064? and FE 4.007, and prior calculation C10, they're going to get 59.3, and it will, because, all right, so it's still going to be, once you plug it in, 59.3, it's going to be 65 millimeters. So we go back here, what would have happened is I would have plugged it back into the C10. 59.3 is below 59.3. All right, so that's below 63.7. This is a little bit crooked. All right, and boom, 65. 65 is still there. 65 is the last one we picked. So all that stuff is fine. And what we want to do is pick that 65 millimeter bearing, and that was what we were assigned to do.